Hi guys, myself Manoj. I'm from Sri Venkateshwara College of Engineering from Electronics and Communication Department. Today the subject is VLSI design and the topic is working on MOS transistor in different modes. MOS transistor. A MOS transistor typically consists of three terminals, namely gate, source and drain. Working of MOS transistor in accumulation, depletion and inversion mode. EVO is equals to vacuum energy level, the minimum energy an electron must have to free itself from the material. Phi m is equals to work function of the metal. This is the energy difference from the Fermi energy of an electron in the metal to the vacuum energy level. Phi s is equals to work function of the semiconductor. This is the energy difference from the Fermi energy of an electron in the semiconductor to the vacuum energy level. X is equals to electron affinity of the semiconductor. This is the energy difference from the conduction band minimum in the semiconductor to the vacuum energy level. Note that this energy does not depend on doping EC minus EF. FB is equals to phi s minus x in the quasi-neutral region where the bands are not bent or in flat band. Now let us see what happens in accumulation mode. In accumulation mode, Vg is greater than 0. For an n-type semiconductor, when Vg greater than 0, the metal Fermi energy is lowered. The insulator has an electric field across it that terminates almost immediately in the near perfectly conducting metal, but terminates over a finite distance in the semiconductor of finite resistivity. The charge model indicates that negative charge must be created in the semiconductor near the interface. This charge is in the form of electrons. Since N is equals to Ni exp into EF minus EI divided by KT, the electron concentration in the semiconductor near interface increases. This is called accumulation. Now let us discuss about depletion mode. For an n-type semiconductor, when Vg less than 0, the metal Fermi energy is raised. The insulator has an electric field across it that terminates almost immediately in the near perfectly conducting metal, but terminates over a finite distance in the semiconductor of finite resistivity. The charge model indicates that positive charge must be created in the semiconductor near the interface. This charge is in the form of ionized donors. Since N is equals to NiExp into EF minus EI divided by KT, the electron concentration in the semiconductor near interface decreases. This is called depletion. Now let us discuss about inversion mode. For an n-type semiconductor, for higher magnitudes of bias Vg less than 0, the Fermi energy near the interface crosses the intrinsic energy and the type of material swaps from n-type to p-type. The charge model indicates that positive charge must be created in the semiconductors near the interface. This charge is in the form of ionized donors and holes. For an n-type semiconductor, for still higher magnitudes of bias Vg less than 0, the hole concentration continues to increase, resulting in a very high concentration of holes near the interface. This is known as strong inversion. This diagram shows accumulation, depletion and inversion modes. In accumulation mode, Vg is always less than 0. In depletion mode, Vt greater than Vg and it is greater than 0. In inversion mode, Vg is greater than Vt. Now, thank you for watching this video guys. See you in next video.